Alright guys, we're going to start with Unit 4, Lesson 1. Write as many equivalent expressions for each as you have time. So when we talk about expressions, expressions are different than equations. Equations have equal signs. Expressions are just what could I get that is going to give me about the same value as 10, or the exact same value as 10? How could I use an operation? So maybe I would do 9 plus 1. Or maybe an expression could be 5 plus 5. So these are kind of addition ways to do it. 2 plus 8. 10 plus 0. What if you had 4? Yeah, that's good. 4 plus 6. Alright, so those are all addition ways. How about multiplication? I could go 2 times 5. I could go 1 times 10. I could go half of 20. Those are good ways to get to 10 using multiplication. I forgot subtraction. So subtraction, we could go 11 minus 1. We could go 12 minus 2. We could go quarter of 40 would also work. So here on the subtraction one, this is another one that I just thought of. You could actually go like 8 minus negative 2. And then remember what we do here with this subtract a negative. You could change that into a plus sign, or 6 minus a negative 4 would also work. So we've done addition, multiplication, subtraction. The only one left here is division. You could go 20 divided by 2 or 30 divided by 3. Those would all give you 10. Let's move on to 2x. If we're going to do addition, that would be x plus x, or 0 plus x plus x. Multiplication would be x times 2. X times 2 would work. Let's see, subtraction. You could have 4x minus 2x. 4x minus 2x would give you 2x. Division-wise, 4x divided by 2, or 6x divided by 3. Those would all work for the warm-up. Alright, let's get into the lesson. Diego writes a sentence of equivalent equations by making one move to each line. Next to each arrow, write the move, what the move is. So if I look here, it's going from x to 2x, and this side it's going from 8 to 16. So I know it's timesing by 2 on this side, and it's timesing by 2 on this side. Now from this step to this step, I've got 16 and 20. Looks like I'm maybe adding 4 here, and yep, on this side I'm also adding 4. And then from this side to this side, this didn't change. So I'm going to put no change here. And on this side, it went from 2x plus 4. It looks like it pulled a 2 out of each term. So this is called factoring. So if I pull a 2 out here, that would just be x. And if I pull a 2 out here, that would be a 4. So this is factored a2 from each term. And what's important here to know is that this equation is equivalent to this equation. Right? As long as we're doing the same thing to both sides, it still stays balanced, or it stays equal. So x equals 8 is equal to 2x plus 16, which is equal to 2x plus 4 equals 20, which is equal to 2 factored out of 2x plus 4, which is 2 parentheses x plus 2 equals 20. These are all equivalent to each other. Write your own sequence of equivalent equations starting from x equals 12. Use at least 3 different moves. Alright, let's see. Maybe I'm going to times by 3. And so this would give me 12 times 3 is 36, and x times 3 would be 3x. Then let's see, let's minus 6 from both sides. So that would give me 30 and 3x minus 6. And then finally, I'm going to do what Diego did up here. I'm going to factor a 3. This side is going to stay the same. No change here. But if I pull a 3 out here, this is going to be 3 parentheses x minus 2. And a little bit about what we're doing here is if you have like 2 parentheses x minus 5, let's say. This, to go from this to this, 2x minus 10, to go from this to this, we call the distributive property. But to go from this to this, we call it factoring. Okay? All right. 1.3, a number puzzle. Pick any number. I'm going to start with 5. 5 times 2 is 10. Add 9 would be 19. Subtract 3 would be 16. Divide by 2 would be 8. And then subtract your original is going to be 3. Now I want you to do the same thing. You could pause the video here. Pick your own number. Take it through these steps. And let's see what you guys get. Well, you should have ended up with 3, right? Let me try another number. Let's go. 7 times 2 is 14. Add 9. Well, 14 plus 10 would be 24, but there's one less, so that's going to be 23. Subtract 3 would give you 20. Divide by 2 is 10. Subtract your original. 10 minus 7 is 3. This is like one of those math magic things. Why does this keep happening? Well, let's look at why. We have a number, and we're going to times it by 2. I'm going to call that 2x. Then it says add 9. Then it says subtract 3. And then finally it says divide the whole thing by 2. And lastly, subtract your original. Well, let's clean this up. 9 take away 3 is going to be 6. So 2x plus 6, whole thing divided by 2 minus x. Now we're going to do this butterfly method. 2x divided by 2 is x. 6 divided by 2 is 3. And now I have x and a negative x. X and a negative x equals 0. And look what I'm left with. So in the equation, I ended up reaching 3. Alright, let's keep moving. Here's our summary for today. Equations are equivalent if values for variables that make one equation true also make the other equation true. One way to create equivalent equations is to correctly use what we call valid moves. Okay, valid moves are sometimes referred to as inverses. So the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of division is multiplication. And like the inverse of something squared is the square root. So these are all inverses. They all undo each other. The other thing to remember about equations, as long as you do the same thing to both sides, right? As long as you're doing the same thing to both sides, you're going to keep those equations balanced. So the distributive property, taking 2x, 2 times the quantity x plus 6 is equivalent to 2x plus 12. Now remember, to go this to this, it's called the distributive property, but to go from 2x plus 12 to this is called factoring. You can combine like terms. 2x combined with a negative x, or 2x take away 1x is going to be x. And then 1 plus 5 is going to be 6. Adding the same thing to both sides. Subtracting the same thing from both sides. Multiplying each side by the same non-zero value. Dividing each side by the same non-zero value. For example, all of these equations are equivalent, right? 2 times the quantity, 3x plus 1 minus 5 equals 15. Okay, you add 5 to both sides, would be 20. Negative 5 plus 5, that would just go away, right? If we added 5 here, added 5 here, these go away. We get 2 times the quantity 3x plus 1 equals 20. From here, just on one side, they did the distributive property. So they did 2 times 3x is 6x, 2 times 1 is 2. So this equation is equivalent to this equation. Then they subtracted 2 from both sides. Right, that gives us 18. That cancels, gives us 6x. Finally, they multiplied by 1/6, or another way to say that is they divided by 6, which would give you 3 and x. All right. So all of these are going to be equal. Those are all equivalent equations. All right, let's take a look at your homework for tonight. Actually, let's look at the cooldown. So here's the cooldown. Label all 4 zeros and describe what happens in each move. So I'm looking at 7 and it went to 4. It looks like they subtracted 3 from both sides. So yes, subtract 3. Subtracted 3 from both sides. Then they're going from 4 to 2. Now they could subtract 2, but over here they did not subtract 2. They actually divided by 2 on both sides. So that would give them 2. So there's 2 ways to think about this. You could call this divided by 2, or you could say multiplied by 1/2. So 2 ways to think about it. Are these equivalent? The answer is yes. These are all equivalent because we used what we call valid moves. All right, let's take a look at our homework. Label the arrows to describe each move. So 4 to 12, x to 3. So over here you might think something like, maybe I added 8, but over here we did not add 8, so it's got to be the same on both sides. Looks like I am multiplying by 3. Multiply by 3, we did that on both sides. Okay, x times 3 becomes 3x, 4 times 3 is 12. Good. Now we're looking here, and it looks like we're adding 4, add 4, add 4. That's good. So now we're here. What did they do here? It looks like they split this in half, split this in half, and split this in half. So what they did was they divided by 2. Or another way to say that is multiply by 1/2. Now all of these, because we did valid moves, are equivalent. They're all equal to each other. Question number 2. Claire asked Andre to play the following number puzzles. Pick a number, add 2, multiply by 3, subtract 7, add your original number. Andre's final result is 27. Which number did he start with? Here's how I started to break this one down. Pick a number. I'm going to call that x. Add 2. I'm going to call that plus 2. Multiply by 3. Now we're going to multiply the whole thing by 3. So I'm going to go like that. Then subtract 7. And then finally add your original number. Now this has to equal 27. So I'm going to start here. 3 times x, I'm going to distribute. 3 times x is 3x. 3 times 2 is plus 6. Then I have minus 7 plus x equals 27. 3x, I'm going to combine like terms. 3x plus x is 4x. And now I have positive 6 minus 7. It's going to give me negative 1 equals 28. How do I get rid of this minus 1? Well, I'm going to do the inverse, which is adding 1 to both sides. 4x equals, I got to go back, mess this up. This is 27. There we go. Add 1 to both sides. That's going to give me 4x equals 28. And then the inverse of multiplying by 4 is dividing by 4, which means x is equal to 28 divided by 4, which is 7. All right, label the arrows to describe each move. So the first move is just combine like terms. This side had no change. Okay. So then to go from this one, I have no change on this side. But over here, what did they do? They did 3 times x, 3 times 1. They did the distributive property. They distributed. That gave us 3x plus 3 equals 7. And then it looks like from 7 to 4, it looks like they subtracted 3. Subtract 3 from both sides. And then finally, to get x by itself, their final step, instead of multiplying by 3, divided by 3 by 3. All right, let's take a peek at question number 4. Select all of the given points in the coordinate plane that lie on the graph of this equation. So remember, this is x and this is y. So I would have 4 times -1 minus -7, and that has to equal 3. 4 times -1 is -4. Subtract a negative, we're going to change that into a big plus sign. And -4 plus 7 is 3. A is on that line. All right. 4 times 0 minus 3 equals 3. Well, 4 times 0 is 0. This would leave me with -3 equals 3. That one is not going to be on the line. 4 times 3/4 minus 0 equals 3. Well, if I turn that into a fraction, I can now cross cancel, and I get 3. 3 take away nothing is 3. That's on the line. Let's try 1. 4 times 1 minus 1 equals 3. 4 times 1 is 4. 4 take away 1. Well, certainly that equals 3. All right. 2. 4 times 2 minus 5 equals 3. 4 times 2 is 8. 8 take away 5 is 3. So we get 3 equals 3. And one more to go here. 4 times 4 minus a -1 equals 3. 4 times 4 is 16, minus a negative, that would turn into plus 1. That would get 17 equals 3. No, that doesn't work. So cross those off. Question number 5. A store is designing the space for rows of nested shopping carts. Each row has a starting cart that is 4 feet long, followed by a nested carts. So 0 nested carts means there's just the starting cart. The store measures a row of 13 nested carts to be 13 feet long and a row of 18 nested carts to be 31. Create a graph of the situation. How much does each nested cart add to the length of the row? Explain your reasoning. C says, if the store design allows for 43 feet for each row, how many total carts in a row? All right, so I have length here and I have carts here. So I'm going to make a little T-chart. So here's my T-chart. I'm going to start with 0. And I've got 0, 4. Because 0 nested cart means there's just one starting cart. And it looks like the starting cart is 4 feet long. And then they gave me 13 and 23.5. And then they gave me 18 and 31. Let's see. If I go by 2's, will it fit? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. 32. Okay, this will be close enough. So we'll go 0, 4, 1, 2, 3, 4. Maybe I got to go by 2's on this side too. So we'll go by 2's. 2, 4, 6, 8. So 0, 4 would be here. And then 13, 2, 4, 6, 8, 10, 12, 14. 13 would be 23 and a half. 8, 10, 12, 14, 16, 18, 20, 22, 24. So 13, halfway in between, would be 23 and a half. So about, maybe about right there. All right. All right, so now we need a couple pieces of information. If we wanted to come up with an equation, we could come up with an equation. We'd need to know the slope, and we need to know the y-intercept. Well, we know the y-intercept. The y-intercept is 4. Okay, the slope we could do delta y over delta x. So what is my change in y? So if I go from 23 to 31, I get 8. So this is how my y is changing. And then from x, my x is changing from 13 to 8, which is 5. So it looks like each card is going to give me 8/5. My equation would be y equals 8/5 x plus 4. Alright, so now we can answer the question, how much does each nested cart add to the length of the row? This would be 8/5 of a foot. 8/5 of a foot. If the store design allows for 43 feet for each row, how many total carts would fit in a row? Well, the total length is 43, so I'm going to go 43 equals 8/5 x plus 4, and now I'm going to solve it. So I'm going to minus 4 from both sides. That gives me 39 is equal to 8/5 x. How do I get x by itself? Well, I'm going to multiply by the reciprocal. The reciprocal in this case is 5/8. I'm going to do that on both sides. I would go 5/8 times 39. It's 195/8. I'm going to change that into something a little bit more understandable. It would be 24 3/8. How many total carts would fit in each row? It would be 24 carts. If you put 25, it would be over that length. Alright, let's take a look at question number 6. Triangle A is an isosceles triangle with two angles measure x degrees and one angle that measures y degrees. Find 3 combinations of x and y that make this sentence true. So as I am thinking about this, I would have an isosceles triangle with x, x, and y. 3 combinations that would make this true. Well, let's say that your x would be equal to 30. Then you would have 30, 30, which is 60, and then you'd have to have a y value, which would be 120. Let's try another one. Let's do 50, x is equal to 50, x is equal to 50, and that would be 100. Your y would have to equal 80. Write an equation relating x and y. Well, 2x plus y has to equal 180. If you were to sketch the graph of this linear equation in the form of y equals mx plus b, what is the slope? Well, I could really easily change this into slope-intercept form. I would have to just move my 2x. So I'd have to minus 2x from both sides. And so what I would have here is y equals negative 2x plus 180. Okay? What is the slope? My slope is negative 2, or negative 2 over 1. How can you interpret the slope in the context? So what it's saying is that our slope, every time it goes down 2, our y has to increase by 1. Alright, question number 7. Consider these graphs of the linear equations. Decide which slope has a positive slope, which one has a negative, and then calculate each one's slope. So, first of all, this one's going up. So if we draw our little person here going from left to right, if they go down, this is negative. And if they would go up from left to right, that would mean that this is positive. Let's figure out the slope. Now we have to look at the numbers. We can't just go by the squares, or the rectangles in this case. But I can see it's going through this point and this point. So this line is going down 20, so I'm going to go negative 20 and over 1. So my slope is negative 20 over 1. If I look at this line, let's say I go from here to here, this is going up 20. So from 60 to 80 is up 20, and then over 1. So this one has a slope of 20, or 20 over 1. Now the equation, we could write the equation, y equals 20 over 1x, and then the y-intercept is negative 80. That would be the equation of this line. And this one is y equals negative 20 over 1x, but this one has a y-intercept of 120. Alright guys, that's it. That is our video for today. I hope this helped you on your homework, and we'll talk to you soon.